So I'll turn my camera off when Nathan is speaking, correct?
Yeah.
Do you want me to turn my camera off when Joan is speaking then?
Hi,
Yeah.
Nathan.
But once she gets going.
All right.
Yeah. All right. Good afternoon, everyone. Welcome to today's webinar, Underplanting Longleaf Pine, the ecology behind this regeneration technique and lessons learned from a case study in Georgia. I'm Karen Brown. I'm with the Longleaf Alliance, and we're very happy to have Joan Walker and Nathan Klaus with us today to take us through their work on this subject. We do get questions about this from time to time at the Longleaf Alliance, so today is a great chance to learn more about this technique, learn about what can make it a successful way to establish longleaf pine if it's meeting your objectives. Joan is going to start us off today. Joan has had a career as a botanist and researcher with the U.S. Forest Service, and she is currently retired from the Southern Research Station. And Nathan is currently a wildlife biologist with the Georgia Department of Natural Resources. I'd also like to introduce Jacob Barrett and Cody Pope. They're both with the Longleaf Alliance, and they'll be just helping to moderate the chat and the Q&A today. Before I turn things over to Joan, just have a couple words about the webinar format. We do encourage questions as both Joan and Nathan are giving their presentations. We just ask you to enter those in the Q&A portion of your Zoom toolbar. And we will collect those and get to those towards the end of the webinar today. If you would like to introduce yourself or have any other discussion, that can go in the chat. So I see a few of you are already introducing yourselves. We'd love to see who's on and where you're from. So Joan, it'd be great if you could take over the screen and begin when you're ready.
Okay. Good afternoon. It is afternoon, I think. I'm happy to be here and share what I've learned about underplanting in longleaf. As Karen mentioned, I am retired from U.S. Forest Service Southern Research Station, but I also work for National Forests in Florida. So I had a little experience on the ground working with all kinds of managers of all stripes. My training is actually in, I would call myself a botanist first, a plant ecologist second, or maybe vice versa. I was really interested in the understory, the diverse ground cover that's found in longleaf systems. But when I was trying to figure out how to restore that and take care of that, I really quickly learned, of course, that it depends a lot on the conditions created by the canopy. So out of necessity, I learned and worked and wisely connected with real foresters and real silviculturists to help learn about understanding or underplanting in longleaf pine. So let's get started. We are going to have sort of a tag team presentation here. I'm going to start out with a little bit of an introduction to make sure we're all on the same page with terminology. And then I'm going to talk about a research project that we conducted 10 years ago already that investigates the feasibility, like, is it possible and under what conditions? After that, Nathan's going to continue with reporting on a case study that he did in a mixed pine under a mixed pine hardwood canopy. He's going to add some information about if it can be accomplished practically and how to address some management or post-planting issues of management. And finally, we'll end up with an opportunity for questions and discussion. So hang on to your hats. Let's get going. The longleaf system, of course, is, you're familiar with it. It's characterized by an open canopy of pines. Generally a single species, longleaf pine, though in some cases some incidental other species or mixed pine species, or even some hardwoods mixed in the canopy. The ground cover is generally herbaceous with some low shrubs in particular. And this ground cover is linked with the canopy by fire. Both the condition of the canopy and the condition of the ground cover are really important for sustaining this ecosystem. And restoring those functions is important for restoring the whole system. It's known, of course, and valued for its diversity and biodiversity, wildlife habitat, bunch of reasons. But the tree itself, the species, of course, is valuable for in its own right, producing quality products, producing pine straw, producing fuel for sustaining the system. It's also desirable from a management point of view. Seedlings are disease resistant. The system can be managed with fire, and it's pretty forgiving. So it can be managed on a large scale rather economically. It's wind firm, and in hurricane zones, that's very helpful. So there's a lot of interest in restoring this canopy, but currently areas that were location stands that were once dominated by this versatile species are now dominated by other pine species like slash or loblolly or shortleaf perhaps, or a mixture of pines and hardwoods, or even in lieu of, as a result of no fire management or no recent fire history, sites may now be dominated by hardwoods. So we asked the question, how do we get those? We want to restore that canopy to longleaf. And we really know how to do that pretty well. A pretty standard way of doing it is clear cut, site prep, plant containerized seedlings. Voila, you've got your new stand established. And it's pretty effective. The clear cut provides highlight conditions, which are desirable for longleaf growth or longleaf seedling growth and establishment. And the site preparation, if it's done thoughtfully and carefully, will help control and remove, at least reduce competition, which also is important for establishing the new stand. This approach, clear-cut site prep plant, it works. It optimizes growth. You can do it at a large scale. It's easy to schedule, so it's kind of easy to manage. But the downside is that the time from your existing canopy to a new canopy of longleaf pine is about maybe 40 years or so, and a lot of transition conditions in between. So although that new canopy is the desired long-term outcome maybe for managers, the existing canopy also has value. For example, those existing canopy, whether it's loblolly or hardwoods, provide wildlife habitat. They're important for creating recreation. They provide the aesthetics or the appearance and the values, the enjoyment of a forest as opposed to a clear cut. And they can also have economic income and provide fuels for any residual ground cover. So if we want to eventually get to longleaf, but don't want to lose all those canopy values, we ask the question, can we do this gradually? Can we get a new stand of longleaf started without completely obliterating the existing canopy? So that leads us to the topic of today, which we will refer to as underplanting. And in this case, we're using that term in the most general sense. That is for planting longleaf pine seedlings while some canopy remains in place. That canopy may be different ages, may be different compositions, but it may be a different history, different sites. But underplanting, in the most general way we're using this term, requires planting seedlings under some of that canopy that remains. The advantage of this is that you can retain the value and the values of a forest and a forest community while you're moving into the next stand. It's also, this approach is also very versatile in terms of it's consistent or compatible with a lot of management objectives. For example, increasing age class diversity in your canopy or changing canopy composition to longleaf. And it can provide income in the process of recreating or regenerating the new stand. So we asked the question, well, okay, that seemed like a good idea. Let's just keep some of the trees and plant some longleaf underneath. Well, is that feasible? Why do we think that's a good idea? 2 lines of research suggest that it could work. If you look at natural regeneration in longleaf natural stands, you see one in the background here. There are islands of longleaf seedlings regenerating longleaf coming up in gaps in the forest. So natural regeneration patterns suggest that this can happen. Secondly, there are well-established procedures for regenerating longleaf by shelterwood, the shelterwood method. Both of these lines of evidence are tied to an existing longleaf pine canopy. But what if you're starting with something else? Loblolly, for example. We have a whole new set of challenges. That any of that loblolly left in the canopies, dumping seeds, seedlings grow like weeds, and you've got issues. So how do we work with those challenges? We know from research that growth is related, growth in longleaf seedlings and survival is related to light. Differences in growth. Let's see if I can get my pointer here. This bottom axis here is a measure of how much light. So more light on the right axis, less light on the left. And this is a measure of seedling biomass or seedling size. In year 1, you start to see a difference, but this increase in the value, the importance of light increases through time. But I get back. There we go. In addition, we also know that light decreases as basal area increases, shown in this graph. Basal area in a forest is increasing. That light measure of light decreases as basal area increases. And that holds true across species, but species at the same basal area can produce different light conditions. The open circles are longleaf, the closed circles are slash pine. So the guidance that we could get from understanding shelterwood, that is natural regeneration under a longleaf canopy, might not be relevant to or exactly translate to regenerating under a different kind of canopy. So we set out in a research experiment, a research study. You can see it was first reported at the Longleaf Alliance in 2016. However, the work started in 2010 or 2009. So that's a long time ago. And we'll check back in on those stands at the end of my talk. This project, planting longleaf under a loblolly canopy, reported at the Longleaf Alliance, was a project that was funded by the Department of Defense. Now, they have a bunch of loblolly on a bunch of Department of Defense properties. They were constrained they wanted to move toward loblolly for ease of management and for conservation purposes. But they could not clear cut because they also wanted to retain the canopy, loblolly in this case, as foraging habitat for an endangered species, red cockaded woodpecker. So we worked with them to design a project that would help us to develop guidelines for underplanting and this gradual conversion from loblolly to longleaf. So I want to talk about this research project, and it was, as I mentioned, specifically related to converting loblolly to longleaf. But there's some generalizable lessons learned from this work. The longleaf ecosystem varies with ecoregion. On this map underneath here, we have an ecoregion map. We also have located the 2 locations of this study site in Camp Lejeune on the outer coastal plain of North Carolina, the Atlantic coastal plain, and down here at Fort Benning, now known as Fort Moore. We have the location of the second plot, the second block of the second experimental plot. It was designed as a complete block and a split plot, which I'll talk with. The main plots treatments had to do with how we manipulated the canopy. The split plot treatments, that is embedded in those canopy treatments, were some treatments that we call cultural treatments that were designed to benefit, or at least see if they benefit, the planted seedlings. So again, Camp Lejeune will be referred to as CL on the figures that follow, and Fort Moore, FB as in Fort Benning. We had the canopy treatments. We created both gaps and uniform treatments. Today, I'm going to present results from the uniform treatments. The gap results are very similar, with the centers of gaps being similar to a clear cut, and the edges, of course, being gradually thinning out to the same treatment as the control. So in our experimental plots, controls were greater than 45 square feet of basal area per acre. We had a medium treatment that was thinned to 35 square feet, a low basal area treatment, which was around 25 square feet of basal area per acre, and a clear cut. We expected clear cut would provide the best conditions for growing seedlings. And that was sort of the baseline reference, because that was the standard management and considered one of the best ways to get seedlings established. Within those, the cultural treatments that we used were no treatment or a control. We just planted the seedlings and let it happen. We did a herbicide treatment, which I'll give more details for in a minute. And because this was a research project, we had to have a treatment that really wasn't too meaningful in the field. That is, we used herbicides and we also used fertilizer, not generally considered, but we wanted to have a treatment that may benefit in seedlings in a different way. So the canopy treatments I'll talk about today are a single tree selection. They were created by single tree selection. The control was about, as I mentioned, greater than 50 square feet of basal area per acre. A medium basal area treatment of about 35, a low basal area treatment of about 25 square feet, and a clear cut. The split plot treatments, or the cultural treatments, were a control with nothing applied, an herbicide release, or as part of site prep, we did a woody treatment, a treatment to control woody growth using imazapyr in October before planting, and an herbaceous treatment only at Fort Benning along the planting rows after planting. That was for herbaceous control. And then we applied a fertilizer along the rows as a third treatment. We collected some data. We measured a bunch of different response variables related to the longleaf seedlings. We measured individual seedlings. And we also measured light, because we knew that was important. And we measured the vegetation, both woody vegetation and herbaceous vegetation. We did some data analysis, which I won't bother you with. And first, we looked at the light availability to see if our treatments actually created a range of conditions that was meaningful and that we could interpret in terms of how does light change with our treatments, and then eventually how does it affect the response of seedlings. This black line is a baseline that was created in a study by Palik et al. This is the line that was created at Fort Benning that shows definitely we decreased light availability on the y-axis as a function of basal area on the x. We got a range from about 0 to 25 square meters, and this was done, well, this is in meters per hectare, but these data were taken from basal area measurements from around each target seedling. So there are more than, these are seedling level sort of measurements and a regression analysis to determine the relationship. At Camp Lejeune, the range of conditions we created was similar, but you can see that Camp Lejeune at any given basal area resulted in a greater light availability than it did at Fort Benning. Now, this could be related maybe to topography, the height of the trees. We did not try to figure out why that difference was real. We looked at the longleaf pine seedling response. It was variable. This is at the end of 3 years. We still have some in the grass stage, and we have a super producer at Camp Lejeune. Just to show you some data as through time. This is showing root collar diameter, which is related to the likelihood of being able to emerge from the grass stage. Excuse me. Again, these were from individual species data. And you can see that toward the end of the study, that is in 2012, which is about year 5 after planting, the sites were comparable in terms of their height, or in terms of their root collar diameter. Lower basal area, or the clear cut, had the biggest seedlings in both sites. And as you increase the canopy, growth was reduced. This is the stand level kind of measurement averaged across all seedlings. Catch up with myself here. The biggest seedlings were found in the clear cut sites. And again, smallest seedlings in the control with no canopy removed. The brown ones are Fort Benning. The green ones are Camp Lejeune. Again, as a site contrast, we had the capital letters here show that the canopy in clear cut, the trees were bigger, and then all the other treatments significantly different at Fort Benning. However, at Camp Lejeune, the size of the seedlings across all of the thinning treatments were bigger than the unthinned treatment, but they were not different from each other. A site difference, which is reflected in the structure of those communities. We found that those cultural treatments, the no treatment, herbicide, and fertilizer had no effect at Fort Benning, but there was a positive effect of the use of herbicides at Camp Lejeune, and you'll see why in a little bit. We looked at survival, and this is through time, just adding on graphs through time. And I just want to point out that the low survival, this green is the clear cut. There was very low survival at Fort Benning in that clear cut, and they never really did catch up. We would have expected a response more like Camp Lejeune, where the highest survival was in the clear cut, with reduced survival as a function of residual canopy. We attribute this reduced, in this case, it looks like the canopy actually had a benefit, and it did. This occurred during a really prolonged and multi-year drought at Fort Benning. And fortunately for the canopy, the stands with canopy, that's where we had the highest survivorship. So it can really not just depend on site quality, but what is the weather conditions and other kinds of external conditions. We looked at vegetation response, and I just want to point out big herbaceous response in an open gap. But here to take note of a lot of ingrowth of loblolly pine. That was at Camp Lejeune. Looking at vegetation biomass, both herbaceous and woody species did better in clear cut, so light benefited them all. Oops, excuse me. There was a huge response of, so looking at woody vegetation, the tallest bar on the graph is, the tallest bars on the graph are with woody vegetation at Camp Lejeune. And well, hang on a second, let me show you some more. This is just at a stand level, woody stems per hectare. Looking at the two sites again, hardwoods. But when you look at this again, the biggest graph here is loblolly. This is number of stems. This is the main plot. This is clear cut. This is control. The biggest in a clear cut, we had a big problem with loblolly ingrowth at Camp Lejeune. This is a function of, it's a really good site for loblolly. Wet sites, plenty of water, lots of loblolly around, dumping in seeds. It looks here that perhaps the canopy actually had a benefit in suppressing some of that loblolly, though loblolly was an issue. The lesson, the point here is that the herbicides did a really good job controlling hardwoods except for loblolly. There was no effect on loblolly. So it begs the question, if loblolly is in your canopy or something else is really goes gung-ho with canopy, it behooves us to control that in some way. Loblolly, perhaps by keeping some canopy or burning. So I just wanted to summarize the results from our feasible treatments that we thought were feasible. In the percent survival, they were pretty similar. I'm including the small gap here. I didn't include results in a large gap because the large gaps were just sort of bigger versions of the small gaps. The centers were similar to clear cuts. The edges approached some levels of canopy cover until you got into the places where no thinning had happened. So we had overall about 60 to 70% survival, a little less across a gap. Root collar diameter was similar in all canopy covers, except the clear cut was bigger, but there was basically no difference. So there was not a lot of loss of growth by keeping low levels of canopy, 25 to 35 square feet of basal area. The percent of the trees in height growth, a measure I didn't show you before, height growth was fastest in the clear cut, and it was somewhat delayed in the medium basal area and the low basal area. So it's going to take a little bit longer. This was at 5 years. It's going to take a little longer to get your trees into the canopy. The probability of reaching the canopy so a probability, if you're a seedling in a clear cut, you have an 80% chance of reaching height growth within 5 years. That is somewhat reduced again with the presence of a canopy. So we have some general lessons here about management, that vegetation response will depend on the initial vegetation conditions and site productivity. Natural regen of loblolly will vary with conditions, variation in seed crop, and the initial vegetation condition, etc. So if a site is really favorable for loblolly, and this was again a research project that was focused on loblolly, the harder it will be to convert longleaf with canopy retention, because you got to fight the onslaught of loblolly seedlings. We found that if they got to be about 6 feet tall, you weren't killing them with the prescribed fire that was used on our sites. The second rule of thumb, that if it's not possible to burn every 2 to 3 years, stand conversion with retention may not be a good bet. It is real, especially if you're retaining slasher loblolly that have some pretty fantastic recruitment rates if the site is good. So again, a couple more questions about managing the canopy. Should you thin by single tree selection versus patch cutting? Well, The biggest difference in the end is the determination of it determines the arrangement of regeneration relative to canopy trees. You need to consider the long-term plans for that stand. If it is to eventually replace the existing canopy, which will require additional cutting and perhaps additional planting, you may want to concentrate your regeneration into gaps, because you can get around, not kill your loblolly recruitment, make a bigger gap, plant a few more trees. So need to consider the capacity to do intermediate treatments like burning, canopy removal, and hardwood control. We had some specific guidelines from this research project that we recommended retaining an intermediate basal area, 25 to 35 square feet per acre. You get slight reductions in seedling growth and a somewhat suppression of mid-story development. That is that hardwood or even invasive pine competition that's going to slow down your trees. Or if you want to use gaps, we recommend quarter acre gaps or 10th hectare gaps. Gap performance in the center was similar to the clear cut. Average performance was similar to an intermediate basal area retention. So this research project stopped at measuring trees at about 5 years. So we had some trees in height growth. We had up to 80% in height growth. Some sites had none in height growth, but we had a chance. Well, Ben Knapp, who was one of he was a student at the time, but who worked on this project, is now at the University of Missouri Forestry School of Forestry. And he was able to go back to Camp Lejeune in 2023 and was able to get into some of the sites. You can't get into everywhere all the time when you go to a military installation. But this picture on the left is suppressed loblolly. It was in a small gap. Well, actually, it was in a uniform thinning site. You can see all of the mid-story that's come in. It's pretty clear that management was not able to keep up with regrowth. They're still there. They probably would benefit from fire and maybe survive. The center picture was a clear cut. It received frequent burning. And if you get into this site, there's actually some loblolly both loblolly and longleaf trees established. And burning, you can pretty clearly see, was pretty frequent and effective. Here is a picture on the right that shows some recruitment, and even you might even think that these longleaf trees had actually captured that canopy space and were surviving in a small gap. As you can see by the understory being burned down, fire was used effectively here. So the importance of managing through time can be seen in these pictures, and they were research plots, so we really couldn't guarantee what was happening. So I want to show just a few pictures that underplanting success can look like this. This is a site in southeastern Virginia, at the northeastern part of the range, where longleaf was just about wiped out. We have some forward-thinking managers there working with conservation partners to reestablish longleaf in a place where there's a lot of loblolly. This site is actually at Dr. Bill Owen's site. He heard that original presentation in 2016, and he said, I want to do that. So he had no real good reason. He wasn't sure that it was going to work. We worked with him. He worked with Forestry Commission, and this is what it looks like 5 years after planting. It was about a 30-year-old loblolly stand. It was thinned and underplanted. You can see he burns. There's a fair bit of fuel on the ground, and he burned it at 3 years and 5 years, and he's ready to perhaps to remove some more of the canopy. This is that same site. You can see that there are places that he's well on the way of creating, this is fairly uniform. I mean, there's loblolly longleaf seedlings as far as the eye can see, but there's also patches where the trees are growing faster. And it looks like, I mean, he's got a really good start on creating a natural looking stand with patchiness and healthy longleaf pines. Very exciting. Underplanting can also look like this at various stages. On the right, there's a slash pine plantation that's been thinned to a low basal area in preparation for underplanting. The one on the left is on the same property, different site, but it was thinned for underplanting, not yet planted, but you see there's recruitment of slash pine seedlings, and hopefully that'll be able to be managed either with longleaf or managed with fire to favor longleaf. And just finally, a picture where underplanting is going to be really tough. This is on the Gulf coastal plain of Florida, 25-year-old loblolly densely planted or slash pine densely planted on very wet sites. The understory was gallberry and a bunch of evergreen waxy leaved shrubs. They planted this in thinned it with a row thinning pattern. I think they described it as 4-2-1-2, cut 4 rows, leave 2, cut 1, leave 2, start over again, cut 4. And the longleaf seedlings were planted in the biggest gaps. Unfortunately, the fuels came back so fast that the prescribed fire was so hot that the recruitment or the regeneration was killed, or a lot of it was. And it's going to be tough to make it work in a site like this. I haven't been back. I would love to go back and see what's happening here. But these are the kind of sites that are really hard. So I wanted to walk you through this research study and suggestions, share with some of the suggestions that we had about what might work, what might stop it from working. And I wanted to show you some pictures from across the range of underplanting experiments at different stages. I'm going to pass this over now to Nathan. Hey, Nathan. And he's going to take you into the intercoastal plain of Georgia in a study site that looks quite different from the research study sites. So I'm just gonna pass it over to Nathan and take it away.
All right. Well, like I think most everyone, that was the first time I've actually seen that talk. That was really cool.
Thanks.
Thanks for sharing that, Joan. So, I mean, some of the things that you were talking about, we've actually observed also, we did some underplanting in the sandhills near Fort Moore and had the same sort of scenario where the clear cut had a more or less a planting failure. I think we lost about 70% the first year to drought. And the trees, the seedlings, the longleaf we planted underneath a loblolly stand did a lot better. So we've observed some of that kind of stuff too. That's there's definitely some surprises when you start messing around with underplanting, and you know, it's not necessarily all bad. It's not necessarily that you're gonna see, you know, poor survival or slow growth or all the other things that you get warned about when you try something like this. Let me see if I can get my screen set up. Hopefully everybody can see my screen. So one other thing I wanted to point out also is just how important it is to do long-term research. So you know, Joan's project was probably at least, you know, looking at about a decade or so when all in, and even then there's still a lot of question marks, and you know, is this going to work out long term? I've been lucky enough to work for the Georgia DNR for 26 years now, and so I've actually had a lot of opportunities to try things like this, and then maybe try it again with some adjustments and learn from my mistakes and get better over time. And it just goes to show how important it is, though, to support places like our Southern Research Stations, where Joan worked for so long, or Archibald or Joan Center. You know, it's really hard to do this kind of research with a master's degree student that might only do one or two field seasons, or even a PhD student that does 3 or 4. You just don't get answers when it comes to forest restoration in that short of a time span. So I'm going to talk to you a little bit about some of the longleaf pine underplanting that I've done. This is a project I did with help from my wife, Dr. Joyce Klaus. She's a botanist, has her own business, but she's also a very good statistician, and she's always happy to, fortunately for me, always happy to help me with data analysis because I'm not always the best at that. Besides having the benefit of being able to do long-term research at Georgia DNR, one of the other really great parts of my job is that I've gotten to work for most of my career on Squirrel Bluff Wildlife Management Area. Hopefully most of you heard about it by now. I love to, talk about it. It's one of my favorite places. It's been just an incredible honor in my career to get to work in this landscape. Squirrel Bluff is on Pine Mountain. It's on kind of the eastern edge. This is an elevation map for Georgia, so white is higher. And you can see that little stringer of mountains there in west central Georgia where you don't expect mountains to be. And the star is Squirrel Bluff. And you can see by the county lines even where the Flint River runs right through the middle of Squirrel Bluff. Squirrel is we've managed to triple it during my time, and so we're at about 8,000 acres now. And there's really two blocks, one on the west side of the Flint River and one on the east. And the west side is, fortunately, for a lot of reasons, the bigger of the two blocks. And the west side is in pretty nice shape. After 20 years of restoration, a lot of it looks like this. These really inviting, beautiful woodlands with montane longleaf. So rolling grassy mountains with post oak and blackjack oak and sand hickory and a lot of longleaf, much of it old growth. Really spectacular place to go explore. The east side ain't all that. So this is what we're dealing with on the east side, and it's probably a scenario that we're all pretty familiar with. It's an old field. So this was farmed 70 years ago. It was abandoned. It's been logged a few times, none of it really done well. And so what we're left with is kind of a mess. It's got all those things that we like to hate. So sweet gum all over in the understory and, some skanky looking loblolly with a lot of fusiform rust in it. But it also has some things that are redeeming. So you can see even in this photo point that there's some little blue stem in the foreground. After 70 years, some of the ground cover has started to sneak back in, even though it's not abundant. And so there's some value to these places that we don't want to lose. We wanted to keep those blue stems and try to get them to thicken up. That's going to be a really important part of any restoration, is getting our fuels, especially our grassy fuels, in a good condition. And then we also wanted to try to return longleaf to this stand. And there's some longleaf around, but there's not much. It's mostly loblolly. And so those are really our objectives. We wanted to keep our ground cover, which, believe it or not, that isn't bad. It's a good place to start, and try to get the longleaf back. So Joan did a great job of talking about this. I mean, one of the obvious things that many land managers reach for is a clear cut and plant. That would get it done. Just get rid of that loblolly, get rid of that sweet gum, and do a heavy site prep and plant longleaf. But the downside of that is that one of the downsides is we want to keep our ground cover. Another downside, though, is that especially back in 2005 when we were doing this, that was a state park. And so we can't just go in and clear cut a state park. That often doesn't go well. A lot of recreation, a lot of visibility. And so that wasn't a tool we could use. Another idea might be a seed tree cut, but again, we don't have much longleaf in the overstory, and so that's not going to work very well. We're just going to end up with a sea of loblolly. I think, Joan nailed it with that. It's just going to be nothing but a fight with that loblolly. So what to do? So we decided, against a lot of warnings from our foresters, to underplant. There's some obvious pros to that approach. One is the aesthetics. We're not going to clear cut it, so the average park user is going to be able to still enjoy it and not know really much is going on. We're going to avoid that heavy site prep that might have eliminated our blue stem. We're hopefully going to keep a more or less stable, or hopefully improving, wildlife habitat. Most of you know that when you clear cut, it creates some pretty good wildlife habitat for a very short period. But then, as your longleaf or loblolly or whatever it is starts thickening up, you're going to go into a stem exclusion phase. Everything gets dark. There's no ground cover. There's no cover. And your quail disappear. Your Bachman sparrows disappear. Your gopher tortoises disappear. All the things that we're trying to manage longleaf for don't thrive and you've got to wait 15, 20 years before you finally get to thin and start to get that habitat to come back. We didn't want to go through that bottleneck. And then lastly, we want to enjoy what we've got now. And Joan mentioned it's going to take maybe 30 or 40 years to get that stand into an open grassy longleaf condition that we all want. And let's see, in 40 years, I'll be 92. I don't want to wait that long. And especially if you're a private lands biologist, you've probably heard this before. Most people can't afford to buy a big tract of land when they're in their 20s. And so most of our private lands people that we're dealing with, the landowners we're dealing with, are in their 50s or 60s or 70s. And when you propose to them, doing a longleaf restoration project, that's going to be one of the first things you hear from them is, I want something now. I don't want to wait 30 years. I'm going to be dead in 30 years. And that's a good point. So underplanting might create an opportunity to accomplish longleaf restoration in a much shorter time span in some ways, but certainly also to give you the aesthetics and the wildlife habitat that a landowner wants in the shorter term. There's obviously some cons, and our foresters were quite loud about this. And we just saw with Joan that they're real. We were warned we're going to have slow seedling growth. Our longleaf are just going to sit there for years. We might have low seedling survival. And then the big one is that, even if you manage to overcome the first two obstacles, what are you going to do when you need to thin again? The foresters are going to come in there. They're going to be throwing trees all over the place. They're going to be skidding, driving all over your seedlings, and you're going to lose all those seedlings in 15 years anyway. So why bother? Don't do it. So in spite of that, we did it. And in 2005, seems like a long time ago, we planted longleaf seedlings under an existing mixed pine hardwood stand. We didn't do it thin ahead of time. We just planted. And that fusiform rust I was talking about was actually a bit of an ally in this scenario because it created a lot of canopy gaps for us. We were seeing loblolly dropping out left and right, and we wanted a longleaf to capture that gap whenever it was created. We didn't put a lot of seedlings out. We just put out 145 trees per acre, which is about a 20 by 15 spacing. It wasn't a super open stand, but it certainly wasn't closed canopied. You can see in these photos how grassy it was. You don't get that kind of blue stem grass, in a completely closed canopy, but it wasn't wide open either. Basal area when we started had a very wide range, anywhere from about 30 to probably 100. So to try to get at some of these concerns that our department had, our foresters had, we did some adaptive management. We installed some monitoring plots. And so what we did is we painted trees brightly so we could see them from a long distance. And we did it on four belt transects. We did 2 plots like this, so 8 total transects. And we used a laser rangefinder and measured the distance from where we were to that center tree to give unique identification of each longleaf seedling. And as we walked along and we would encounter a longleaf seedling, we'd shoot the distance back to that center tree and figure out if it was one of the seedlings we'd monitored in prior years. And if it was, we would collect some information about that particular seedling at that site. The information we collected was mostly trying to get at competition. So we were trying to measure things like what are the species of the 5 closest trees to that seedling and how close are they? How big are those overstory trees that are close to our seedlings? We measured the basal area of the hardwood around each seedling, and then we separately measured the basal area of pine around each seedling. We measured canopy cover, and then we tried to get at hardwood sprout density by using a density board and a fixed radius plot. And then we also tried to document seedling condition and height. So here we are in 2005, the year we planted, and our belt transects encountered 80 longleaf seedlings. And 3 years later, we ran those transects again, and we had 70% of our seedlings left. So about 56. 5 years in, we ran that transect again, and we had 50% survival. Much like with Joan, we were going through a lot of very intense droughts, and that definitely took a toll on these seedlings. And then we did the transects one more time, so this would be 8 years in, and we had about a third of our seedlings still. So right away, you can see that underplanting isn't necessarily the most efficient use of tree seedling, of longleaf seedlings. But could this be improved? That's one question. You know, some seedlings did survive, and what were the conditions like where they survived compared to places where they didn't? And then also a second question is, did it, you know, okay, we lost 2/3 of our seedlings, but we still got a third, and did this meet our objectives? We kept our blue stem. We knew that if we clear cut and did heavy site prep, we wouldn't have met that objective. We kept our aesthetics, and you know, did we get longleaf into the stand? Well, we got a fair number of longleaf in the stand. Whether or not they're going to make the canopy is another question. So we modeled the habitat, did a logistic regression around each seedling, and it was a decent model, wasn't a super strong performer. But one of the variables that came out significant was basal area around seedling. And so there is a very predictable relationship there. The more trees that you had around the seedling, the lower the slower the growth. The seedlings were slow to grow and less likely to survive, it seems. But if you split out that basal area into pine and hardwoods, it becomes there's quite a contrast. So there actually we didn't detect a significant relationship between pine basal area and seedling growth, but we did detect a very strong relationship between hardwood basal area and seedling growth. And as Joan pointed out, you know, there's differences in canopy, and there's especially big differences in canopy Joan pointed out there's differences in canopy or shading by species, and that's especially true for hardwoods versus pine. So hardwoods cast a whole lot more shade than pine trees do, and so they're slowing down our seedlings from growing. So that kind of raises the question, does that mean you just need to eliminate all the hardwoods? Because that's not really what we wanted to do. We're restoring a montane longleaf ecosystem, and that's not a pure pine system. There's a lot of upland hardwoods that are in the mix, or should be in the mix. So we didn't want to do that. So hit the pause button on that study, and we're going to take a quick look at another project. In 2011, we decided to try this again, and this was our starting point. This was the stand. Again, you know, just pretty raunchy looking stuff. And we did a marked timber thin in it and did an understory spray to control the hardwoods with a Garlon escort mix that would keep our most of our ground cover. And this is what it looked like in 2015. And we also planted longleaf into this stand. And so they're down in there. You can see we did it a little differently this time. One thing we tried to do, well, for one thing, we did a timber thin ahead of the underplanting. But as we were marking this thin, we tried to clump hardwoods a little bit. So we tried to keep kind of pines in one area and hardwoods in others, and you know, it was still all mixed together, but it wasn't evenly distributed like a lot of our first study was. And here's what it looks like in 2017. The longleaf are in there. Can't really see them in the picture, but we're very happy with the outcome here. We had about a little bit more than 50% survival of seedlings, and if I had time to run out there and take a picture of it in 2024, you'd see longleaf that are probably about 5 or 6 feet tall in this gap. They're doing really well. This is actually now one of our red-cockaded woodpecker clusters, so we're really happy with that outcome. All right, we're going to go back now to the first study, to the first underplanting. So here we are 12 years into it, and it's time to do it then. So those seedlings, those 30% of seedlings or so that survived, are in for it, right? The loggers are going to come and they're going to drop trees on them and run them over with their skidders, and they're all going to die. At least that was the prediction. Were those foresters right? Well, yeah, in some ways they were. Our seedling survival was low, but we found a way to improve it on the next go round. We did a thin, and we tried to kind of clump our hardwoods a little bit. Our target basal area, by the way, was about a 40 in our pine areas. But if there's one or more hardwoods in the mix, we'd shoot for about 30. And that worked out really well. Our seedling growth, yeah, it was slow, but do we care? I don't really. I mean, as long as the longleaf are getting up there into that canopy eventually, if it takes a little longer, that's okay. For our purposes, we're not here to try to grow longleaf fiber as fast as possible. So longleaf was successfully returned to the stand, and that to us is what mattered. But what's going to happen when we do this next then? That's the big, scary question mark. All right. So to kind of formalize these questions a little bit better, are we going to see any kind of relationship between logging intensity and seedling mortality? And, some areas they're already maybe at a 40 basal area and we're not going to take too many trees out of there. And other places it's maybe, 110 at this point, and we're going to have to cut half those trees. So is there going to be a difference in seedling survival between those intensities of logging? Also, is there any rule of thumb for when seedlings are likely to survive logging? So maybe if we waited another 5 years and those seedlings were a little bit taller, would they do better because they're more visible? So ahead of the logging, I went out and GPSed 150 seedlings. I marked the base of the seedling with paint very discreetly. You didn't want to raise their visibility any. And I measured their height and the basal area pre-logging and the density of other longleaf seedlings around it. And then post-logging, went back and saw what happened, how many of these things were still there. So actually Google had one of their satellites fly over and get a picture while we're logging, and you can see the deck there and the cutter, and they're working hard at work in there. So this is spring of 2017 when the logging happened, so 12 years after we underplanted. And here's what we saw. This is longleaf seedling height in meters along the bottom and the percent survival. So roughly speaking, there are essentially two outcomes. The smaller seedlings, we lost about half, maybe more like 60% of them. The taller seedlings, we lost about maybe 30% of them. So how tall is tall? Seedlings that were over a meter tall, especially if they're over 2 meters, had a pretty good survival. So it was not all the doom and gloom that we were worried about. We actually had decent survival of the taller seedlings. And honestly, 40% survival of the smaller ones wasn't bad either in our book. There's still a lot of seedlings around. Survival by intensity was very predictable. Where there was no logging, we had didn't lose too much. And where there was heavier logging, we tended to lose more. So it's change in basal area along the x-axis and percent survival on the y. So conclusions. Seedling growth was driven by tree basal area. When we underplanted, it was really hardwood basal area that controlled the outcome. Sapling competition, canopy covered, a lot of the other things that we measured didn't really predict seedling growth. And seedling survival, for us anyway, we didn't find that there was anything that predicted it well, because it was really overwhelmed more by things like whether or not that seedling was planted well and it survived the first year, and also the droughts. So those were really in the driver's seat for us, much more so than the competition that came later. Basal areas, we decided that there's basically a cutoff. 40 feet per acre or lower is what we recommend if you're going to underplant in pine, and probably more like 30 or lower if there's any hardwood present. During logging, we saw that seedling survival, 12 years later, the seedling survival was related to seedling height. We did talk to the loggers and ask them if they could, try to avoid them. But as the state of Georgia, we couldn't pick our loggers. We couldn't include it in the contract or anything like that. So we were really up to the goodwill of the logger to try to follow our recommendations. And that's what we got. We got about 70% survival, which we were happy with. And then seedlings less than 2 meters tall, we had about 40% survival. So there's still some in there, and they're working their way up, and they've already got a good head start on the loblolly that's trying to come in, or the southern red oak, or other things that are trying to come into this area after a thin. And we were very happy with our underplanting density. Something around 150, 200 trees per acre seems to be about right for our purposes. During this whole time, we burned on a 2 to 3 year rotation, and we included a good bit of growing season fire. In some areas, we have followed up with some herbicide work, just directed spray, mostly trying to keep sweet gum at bay. I'm not sure that has anything to do really with our underplanting. I think that if we had, if we hadn't underplanted at all, and we'd still be fighting sweet gum, we'd still be in there having to work on it a little bit, just because this is an old field site, and sweet gum's, a very tough character. It's hard to get rid of. So from my perspective, underplanting worked for us. We've got longleaf in the stand. We kept our blue stem. We kept our aesthetics. We kept our wildlife habitat. And the vast majority of anything that looks like a gap at this point has longleaf coming up, dominating it. You can see the little longleaf in the foreground. That's very obvious. But if you look a little bit to the left and in the distance, you can see a nice little dome of longleaf coming up back in there in a gap also. And off to the right, if you look closely, you can see a good bit of longleaf kind of coming up in another dome over there. So what we're seeing is really encouraging. It's what we were hoping for. Why do I conclude this worked for us? Mainly because production forestry wasn't our goal. We weren't trying to get 95% survival. We just wanted to get longleaf in the stand. We wanted to keep our open pine. So it really depends on your goal. And really the best part of this is we all live to see it happen. If we'd clear cut and planted longleaf, we'd be looking at a 15-year-old or 20-year-old longleaf stand at this point, which, doesn't have the same appeal. So I want to acknowledge some folks, especially my wife, who's helped me with some of this analysis, Dr. Joyce Klaus, and also one of my wildlife technicians, Ashley Harrington, pictured on the right, did a lot of the work on this project, and was a really valuable friend and partner throughout the many years. So that's what I got.
Thanks, Nathan. Thank you, Joan, too. Those were really good talks to kind of merge together. I think it gave people a lot of food for thought. So with that, we do have a few minutes for some questions from the group. I know some of you have been typing some stuff in there, so thank you for that. And I know we've been getting some direct messages too with some kind of some scenarios. Jacob, Cody, do you want to kind of pitch out a couple of those questions?
Yeah, so I've got one. I'll jump in first. A landowner has property in Georgia where Hurricane Helene just passed through, and thinking about all of this. This particular one has saw timber sized loblolly on it, and now it's got a lot of areas that's just damaged to the point that it has to be all harvested in certain swaths, but it's created more or less canopy gaps that are, I guess you'd call it areas, 30 to 40 basal area that might be, by the textbook, being able to plant longleaf underneath it. But this particular site doesn't have a history of prescribed fire in it. With y'all, what are y'all's opinions on management actions moving forward? Are they setting themselves up for failure? Just planting longleaf in an area that's not been burned? We don't know what's coming back. What do y'all think?
Nathan?
Well, my inclination would be the most important aspect of that scenario is what competition is already established. So if there's a lot of pine seedlings already on the ground, or maybe, yopon, or who knows what, something that's going to be a problem, that needs to be handled first. And it could be handled probably best through some herbicide work, though fire may manage to get the job done. I would also, if there's going to be any kind of salvage logging, I'd get that done before planting, before doing any underplanting. But I think that once all the dust settles from those two things, that has some potential, but depending on how open it is for underplanting.
You said that was a loblolly canopy, saw timber?
Right.
Yeah. I agree. I don't with Nathan about checking out to see what kind of loblolly competition is going to be coming in and how you can manage that. And I don't know, is there no possibility to burn in the future? Or because I mean, I wouldn't probably try to invest in it if there wasn't a chance to burn.
I agree. Yeah, fire is a critical part of underplanting.
Yeah, I think it's as far as a site goes for this particular question, it's an area that's similar to a lot of places that we've seen on private lands. It's been beat up over the years with repeated and heavy-handed herbicide usages, and not expecting a lot of ground cover response, although there may be some there. So, you know, the ability to burn, I guess the question would be, is there going to be a combination of ground cover and needle cast to carry a fire, or is it just not there? So
Yeah, that sounds a little scarier now. Yeah, if I mean, for us, one of our great allies in this process was that little blue stem. So being able to get a hot fire that is fairly homogeneous and that's really important also. So that just goes back. I know I preach about it every chance I get. You know, maintaining ground cover is really important for any restoration project. And the worst thing that you can do is hit it hard with glyphosate or imazapyr as a broadcast spray. It's going to eliminate a lot of these possibilities for a long time.
It
What do you
would be
think, Joan?
interesting to see what kind of ground cover response you do get with that opening in the canopy. But it's old field, so I don't know. Don't have a lot of hope beyond maybe Broom's Edge. I don't know. But I think that would be a determinant.
Yeah, and maybe another option could be to underplant. Tell me, Joan, you've got more experiences on this aspect. Underplant it and then maybe follow it up with a sort of a release treatment 4 or 5 years after you plant. Try to knock back whatever it is that's trying to capture that site and give by that longleaf a little more time to get up. And would that work?
Yeah,
You
but
think?
if it's loblolly seedlings, I'm not sure what you can treat loblolly with that doesn't also do in longleaf. So
Yeah,
that's
there's not a lot of good options.
fires the deal for
Mhm.
that. I don't think we're at a point where you could say, okay, let's plant fine fuels. Let's go in and plant blue stem, create a fire environment, and then start planting longleaf. I don't think we're probably there yet in terms of affordability but
Yeah.
I
We've
think
tried that. We did that
yeah.
on Mayhaw with wiregrass plugs. And we did, it was in gaps and we planted wiregrass and we planted longleaf and it did work, but it was very intensive. It was hard to get crews to plant the gaps. You know, it's very hard to get anything other than a certain spacing with contract crews. But it did work. You know, we ended up planting the grass ourselves. And they burn well now. And we did have to still follow up with a sort of a release treatment to deal with some oak that was trying to capture those gaps.
okay, thank y'all. That's the only question that I've got right now, Kieran.
Yeah, we've got some questions entered into the Q&A function. It looks like this first one is for Joan, but I know Nathan touched on this a little. So Mary Frances Thomas asks, what will happen to Southeast Virginia longleaf trees when logging equipment is brought in for the loblolly?
Well, I think, I mean, it's not state property. And I do know that the landowners are very protective of their planted longleaf. And I had the feeling that there's going to be a lot of eyes on those loggers. And you saw those pictures. There is a lot of longleaf in there. So that in a sense, they can afford to lose some maybe and still have a reasonable stand. So I think some will be lost and it would be great. And I'm going to talk to Bill about monitoring the impacts of logging and just to see how we can maybe minimize the impacts. So I think there will be some lost, but it's going to be carefully watched. I know that because it's a much loved property.
Yeah, and in the pictures, it looks like a lot of them were over or getting close to that 2-meter mark. So
Yes.
hopefully they'll be able to be seen and spared.
Yeah, good point.
So it looks like this next question may be for Nathan. What is a typical seedling survival percentage after 8 years under a clear cut in a standard planting density of about 500 to 600 trees per acre? 33% seems low, but not sure what the comparison percentage is.
So, and yeah, it can really vary year to year in a clear, in a clear cut, 33% is low. But it's not unheard of, unfortunately, when you get these droughts. I've had that more than once over the years. But more often I get, and of course I'm using, Garland Escort typically for my site prep. And I'm getting typically 85, 82, 88% survival, and I'm very happy with that. And that's pretty comparable to what you see with an imazapyr broadcast or even a glyphosate broadcast. That's about the top end. So, yeah, we lost, somewhere in the order of 50% because we underplanted instead of just clear cut. But we were okay with that.
Right. Those objectives were still met.
Right.
Okay, so Ace Haddock asks, are there any insights on hardwood loblolly competition removal post-planting? Burning is best, but not always possible or effective, especially when there are lots of hardwoods.
I mean, there are herbicide options for hardwoods, and directed spray would be the most parsimonious way to do that, I guess. Depending on how pervasive, how big the problem is. I was still not sure about competing pines. I think your best bet still is fire. I don't know of any other way to do that, unless you have the garden club come in with their loppers, which has been done.
Yeah, I guess it depends on what they mean by hardwoods. If it's sprouts, I agree with Joan. If it's overstory hardwoods like what we were dealing with, I would recommend dealing with that before underplanting. And so for us, we dealt with that with a marked thin, and that not only did that serve to give us the more open canopy we needed for the underplanting to up the survival, but it also allowed us to adjust the stand composition. So we were trying to favor species that we thought belonged in that montane ecosystem. So things like post oak and black oak, sand hickory, pignut hickory, that kind of stuff. And we were at the same time eliminating things like sweet gum and water oak and red maple, and greatly reducing other species. So it allowed us to sort of just recreate as close as we could that composition, that stand composition that we wanted.
That's perfect sense. It makes sense to look at where you're at in your management goals and where you're at, in your target species. Karen, it looks like we've got one more question in the webinar chat. It's directed to Nathan. And they ask, did you have the planning crew strictly adhere to the 20 by 15 spacing, or did you give them the ability to make judgment calls and plant gaps when present? If so, how did that go?
Yeah, it is darn near impossible to get a planting crew to do anything other than plant a certain spacing. I've tried many times. My Spanish is non-existent, but I've had the benefit a few times of having a fire crew member who's fluent in Spanish. And on those occasions, sometimes I can get it across that, hey, don't just plant in rows. But a lot of time planting crews really still don't like that. They have a hard time tracking how many seedlings are planted by each individual when you start messing with their spacing. So in general, we've just stuck with spacing and made the best of it, and it's worked pretty well. It's the 20 by 15 spacing or whatever spacing we happen to use is dense enough that if there's a gap, there's several longleaf that are going to land in it, and that's really what we're going for. A long time ago, we were trying to do something more along the lines of what Bob Mitchell was working on at the Joan Center, and other people too, where we would have a gap and we just stack it full of longleaf seedlings and create like a dome, almost like what you would see happening naturally. And I'm not entirely sure that that's necessary. I think that, if you think about what's going to be in that gap, ultimately it's going to be 2 or 3 trees. And if it's two, if most of those are longleaf in my system, then I'm pretty happy with that outcome.
Great. Joan, we have a super quick question for you because we are just a minute or two over time, but do you know what Dr. Owen used for his spacing? It looked
I
pretty
do
dense,
not. I can
a little
find
bit more
out
dense. Okay.
and get that back out there somehow.
Okay. Well, yeah, we'll figure that out. But
Yeah, that's a good question. I
Yeah.
should have asked.
yeah, sure. We'll update it for the next presentation. Well, we are at the end of our time together. So thank you everyone for those great questions. That was really, really good to have those at the end to go a little deeper. And thank you, Joan Walker and Nathan Klaus, for sharing your work and your expertise and presenting that in such a practical and easy to understand way today. I'd also like to thank the Wade Research Foundation for sponsoring this webinar. And if you enjoy hearing this kind of subject matter, be sure to subscribe on forestry webinars, and they can feed you all kinds of topics like this that apply to you. This session was recorded and it will be posted back on forestry webinars in a couple days to a week, just to allow us to process that video, so it can be shared and viewed again on demand. If you are seeking SAF or any other credits, just stay here when this webinar closes, and it'll return you to picking up at that step in order to receive your professional credits. Thanks again for joining us, and take care.
Bye,
Thank you.
everybody.
Bye.